you who love to do that stuff. Okay, so the last part, part D, says the closest distance Now, the fact that they've used distance here is good, because remember when we were talking previously about greatest displacement, the problem there is we were saying the positive negative. Because it's closest distance, it doesn't matter whether it's left or right. It's just the one that gets the closest of the particle to the origin. And what is that also implying about the graphs that I had as choices? If it says the closest distance of the particle to the origin, what's it implying?
It never reaches the origin.
May not, yeah. So it might be that version up there. It could still be closest but on the other side, but it's almost implying that it's this version up here, right? So we'll have a look and we'll see. We'll see whether we come up with a positive or a negative value. So which formula are we going to use?
The X.
The X. So if we want the closest distance to the origin, then what's this word closest? What can that be replaced with?
X approaches 0.
Ooh, okay, nice. So you'd look at a limit. Is that what you're thinking?
I guess. That's what...
Okay, all right, nice idea. Anybody else have an idea of what closest indicates? Another word we've used previously. You know how we go greatest, least, maximum, minimum, closest, furthest? What do all those words tell you to think about?
Second derivative.
Well, or at least your first, so your first derivative in terms of you're going to have a turning point or a maximum or a minimum value at the first derivative. You then decide whether it's max or min when you do the second derivative, don't you? But in terms of what we know of this question being a squared, it only has a minimum value because it's this parabola. So we won't have to go as far as the second derivative in this instance. But if we had a cubic and so we had it going in two directions, we'd have to then decide which one was the minimum and which one was the maximum, right? So closest is implying minimum. And the minimum occurs when dy dx is 0. I can't write occurs. So I'm going to write when x dot equals 0. The first derivative is 0. Okay. So we already had that up here. So from part C, x dot equaled 0 when t equaled 1.5 seconds. So we know when it happened. How do we know therefore how far it was? We go back to
do you put that back in the original question?
Yeah, so remember Finest was saying initially that we should be looking at the distance formula or displacement formula, but we needed a time. So we put that time into our displacement. I've got to find the displacement question. So we've got 4 minus 3 times t plus t squared. And if you do that, I think you get 1 3/4 or 1.75.
Who's whistling is that?
Oh, that would be my son.
Oh.
Hey, Deck, we can hear you. Shh. Now, it talks closest distance, but does it turn out that it's to the right or the left of the origin? Did we end up with a positive or a negative value?
The right.
Right, we ended up with a positive. So therefore, in terms of my diagram, is it the top one or the bottom one? Did it ever, we're talking about the closest value being this turning point. So is it at the positive version or the negative version?
The positive, because it
Right,
doesn't
so
reach zero.
yeah, so this is this one, which is, remember I said that that's what it was implying, but we needed to make sure that that's what was happening. Okay, and it's technically to the right of the origin. All right, little visual summary and then we'll wrap it up because we've gone over time. So let's just have a think of it in terms of genuinely moving in a straight line. All right, so we've got X is here. Remember, positive X is to the right, negative X is to the left. I'm going to put my origin down here because everything's happening to the right of the origin, okay? So we started 1, 2, 3, 4 meters away. So that was when t equals 0. The particle then travelled as close as, if that's 1, 2, 3, there's 1.5, there's your 1 3/4. So it got as close as 1 3/4, 1.75, turned at that point, and by 2 seconds was where? Back at 2, wasn't it? So it's heading that way, but at t equals 2, it was back there. And this one here, well, that's not very clear, was at t equals 1.5 seconds. Okay. Now, technically, I haven't drawn it that it's actually moving in that one direction. So it would just go here, turn, and come straight back along there. But you can't see it if you do that. Now, they can ask you to describe it. So you would talk about where you start, direction you're heading, where you turn, and where you finish up, I guess. And if they ask questions about acceleration or something like that, we'd add that in. So we started 4 meters to the right of the origin. The direction was we were traveling to the left towards the origin. We turned, we turned at 1.75 meters to the right of the origin after 1.5 seconds. And we finished at, in terms of this, like it didn't actually say it stopped, but we finished at, was it at 2 meters? Where were we after 2 seconds? Oh, 1 meter. No, that's the velocity. Where were we after 2 seconds, or did we not work that out? Yes, we did, 2 meters away. So at 2 meters to the right of the origin, after 2 seconds. Okay.
Miss,
Yes.
I'm still a bit confused on the difference between velocity and acceleration. Like,
Okay. So, if
because I know displacement is the distance from the origin, and then the other two I'm just a bit.
yeah, so velocity, think about how fast you're going.
Okay.
Okay. Now, if you're driving your car, unless you put your foot on the accelerator, you're not going to get faster and faster and faster. Okay. So when you, the acceleration part of it pushes something to go faster, and our brake in our car is like the thing that slows us down. It's the thing that's the negative acceleration. Okay. If you had a pedal on your accelerator that could kind of go in the opposite direction, that you could pull it backwards, that would be like the slowing down part of it. So the acceleration is the thing that if you've got a particle and it's moving, it's only going to move at a constant velocity unless the acceleration either comes from behind it and pushes it along and makes it go faster, or if the acceleration is working in the opposite direction, that's going to slow that down. And that's like your brake. Okay. Now,
Yeah.
I'm going to get on to questions to do with acceleration. So I need you guys to get these notes and things sorted. And as I said, I'll post them and I'll post the video. But I want to do a couple more examples with you before I set questions for you to have a go at. So you guys can have a look at some of the revision stuff for the advanced work. I'm happy to do another Zoom tomorrow and wrap up these questions and get you guys to a point where hopefully you'll feel comfortable about the interpretation of the whole thing and understanding what to do with it.